Hello and welcome to Sustainability 310, a basic primer on climate change and greenhouse gases. So the main story with climate change is basically not whether the Earth's temperature has cooled or gotten warmer, because we know from the historical record that temperatures rise and fall, and these are part of natural patterns, but rather how much of this activity is naturally occurring and how much of it is engendered or created or the result of human activity. We call this anthropogenic change. And so we do know that over the past century, as you can see in the slide, temperature has risen. But the question is how much of that rise is due to human activity, what we can do about it, and also um, what are the implications of this change. So, what can we do about it? What are the likely implications of this change, not just for humanity, but the ecosystem in which we exist in? So, we think that the impacts of climate change are extreme weather conditions. And so, it's not global warming or a warming of more than can be expected naturally, but also extreme climatic impacts. What are these impacts? Rainfall, heat waves, floods, droughts, increase in ocean acidity, the melting of the glaciers, ice caps, rising sea levels as a result of that, and others as well. Um, Again, these are just estimates, so please keep that in mind. But for about every 2 degrees of warming, we can expect certain negative impacts, and some of these are outlined here. So crop yields will decrease, precipitation will increase, stream flow as a result of increased precipitation will also occur, and then aridity, right, or desertification. That's another way of saying just you have cycles of of monsoons and then dry weather are going to be disrupted, and you're going to have prolonged dry spells in certain parts of the world, and accompanying these dry spells will be the wildfires. So all of these are expected impacts. Some evidence is presented here of the temperature changes, the high and low temperature changes in the 48 states in the last 50 or so odd years. And what you can see right here, if you were to plot a line through this, is that it is actually trending upwards. The line is trending upwards to the midpoint of each of these bar graphs. So our record our record highs have been higher. So the highs have been getting higher, and then basically the temperature range itself has shifted up, as you can see from this graph. What are the likely health impacts of this? Again, this is based on some of the impacts of the warnings we talked about earlier. But in short, this is an increase in morbidity, which is sickness and mortality, can be expected as a result of these climatic shifts. And there's direct impacts that occur because of things like an increase in heat waves, for example, or disasters, extreme weather conditions. But there's also indirect effects that occur because of changes to the ecological system. As temperatures increase or you have other extreme climatic patterns that develop, the ecology of various areas is going to be changed, and sometimes in irrevocable ways. And this has, not only direct impacts on other flora and fauna and plants and animals, but also the human beings that depend on that ecology. So earlier we talked about human-centered or human-driven change or anthropogenic change, and this is what I was alluding to. Is how much of this exactly is because of human activity? And again, depending on the authorities that you believe, and at least in the scientific community, there seems to be a pretty strong consensus that a lot of this is because of human activities. Here we look at sort of a basic conceptual overview of what the greenhouse effect is. And in short, basically, this is the gradual warming of the Earth more above and beyond what would normally occur because of an increase in the greenhouse gases. What are the greenhouse gases? This carbon dioxide, nitrous oxide, and methane. These are the primary ones. There are others, of course. But basically, these gases act like a kind of like a blanket around Earth. They trap energy and heat within the planet, increasing temperatures more than they would normally increase um, because of this greenhouse effect. And so this increase in temperature, theory goes, will again harm ecosystems in a way that is in many ways irrevocable. I mean, cannot be changed, beyond what has already occurred. And so it's not the main thing of concern here is that it's a, this phenomenon is occurring, and b, the kind of the real important thing is that some of these changes are permanent, cannot be undone after they have occurred. And to what degree this phenomena will happen, to what degree the impact on ecology and then human beings, of course, this is all hotly contested right now. And you can see this in the debates. On one side we have folks who don't believe in climate change at all, and then on the other side, we have sort of the doomsday predictions that everything is going to end. And in reality, the truth, and I hate to use this phrase, is probably somewhere in between. But at least the evidence seems to show that there's a pretty strong shift in temperatures, and a lot of this shift is caused by human activities, and specific sectors of human activities. And here in this chart, you can see this increase over the past 15, 20 years. And a lot of this is coming from the energy sector, and then transportation and agriculture, industrial processes, and waste. And these are not, even though they're shown as separate categories here, these are not necessarily separate, because transport, for example, is used in industrial as well as agriculture processes, and also in waste, right? Some of you may be looking at agriculture and maybe a bit dumbfounded as to why this is here, but there has been a shift, and we'll look at this phenomenon a bit more when we look at food production and trends over the last 3 or 4 decades. But agriculture, basically, especially factory farming, is heavily reliant on the types of things that not only pollute water and streams, but also cause an increase in greenhouse gases. And also the end product of agriculture is also very, very detrimental. What is actually, end product is the wrong phrase. It's the intermediate steps, especially when we talk about animal husbandry, specifically cows and enteric fermentation and methane, is also very, very detrimental to the environment. What is enteric fermentation? Basically, it's the processes that occur inside cows that result in the release of a lot of methane. So we are basically shifting. The story here is that we're shifting to a more meat-based lifestyle, and that in many cases means eating more cows. And we have cow levels that are kind of kept at in these factory farm conditions that are, well, not only not good for the animal, but they're also not good for the environment in terms of the waste produced by the cows that finds its ways, for example, into the runoff and then into water supplies, but also in terms of their methane production by cows. Methane, of course, being a greenhouse gas. So all of these are kind of interlinked, and at the same time, they as the world globalizes, urbanizes, the increasingly developing countries are looking more like developed countries, like the United States of America and other countries. Waste production is going up, industrial processes, agriculture, increasing reliance on factory farming, meat, those kinds of things, transportation and energy, all are becoming more intensive throughout the planet. Okay, here we have our main greenhouse gas, which is carbon dioxide. This is sort of the baseline gas, if you will. We measure other greenhouse gases in terms of their global warming potential with reference to carbon dioxide. So that's kind of a complicated way of saying is that we compare other greenhouse gases to carbon dioxide to see how much worse or not worse they are compared to carbon dioxide. Chart that looks at carbon dioxide concentration, historically speaking, and you can see the present day spike right here. Coincidence? Probably not. Probably related to human activity. Here we have methane, another important greenhouse gas. I mentioned this earlier, and then nitrous oxide. Now, there are other gases as well, These are the fluorinated gases, but these are much more heavily regulated. Chlorofluorocarbons, hydrochlorofluorocarbons, halons, for example. Much more regulated, even though their greenhouse warming potential is much more than carbon dioxide, nitrous oxide, and methane. The limits on their production have ensured that we don't produce them in the kinds of quantities that can be truly harmful. The same, of course, is not the case for methane or nitrous oxide, which are very, very intimately linked to factory farming, or carbon dioxide, which is very, very intimately linked to coal, right? Energy production, as well as other types of energy intensive activities. Our total greenhouse gas emissions. This is 2011 data taken from the EPA. Interestingly, some of this data right now. So as I was mentioning, this is from the EPA, and interestingly, right now the EPA has kind of dialed back their the amount of data they highlight with respect to climate change. And one of the reasons I'm kind of laughing at this is because, again, this is sort of politically motivated, and different administrations, believe or don't believe in climate change and the EPA's role in mitigating climate change. This current administration, the Trump administration, has taken sort of a more skeptical stance on this, to say the least. So this kind of data is a little bit harder to find. It is there. It's just you have to mine for it a bit more. Sources of greenhouse gases, as you can see here. Again, this is the same data we saw earlier, but energy production, transportation, industrial, agriculture are major sources. The earlier chart looked at world production. This is more specific to the U.S. So U.S. transportation, industrial, energy generation plays a much more significant role than agriculture. Okay, and sort of the last bit of information in this primer is, again, looking at these greenhouse gases, carbon dioxide, methane, nitrous oxide, and looking at their global warming potential. Carbon dioxide, as I mentioned, is the baseline gas, so it has a GWP, or global warming potential, of 1. Methane is about 20 times higher than carbon dioxide, so it has a GWP of 20, because the baseline is carbon. And then nitrous oxide has a GWP, or global warming potential, of 300 times that of carbon dioxide. The hydrofluorochlorocarbons, fluorochlorocarbons, are much higher. They're on the scale of tens of thousands of times more, and hence that's why they are more heavily regulated. Okay, thank you for tuning in. I hope this was helpful in terms of understanding sort of the basics of climate change and greenhouse gases and their global warming potential.